Yes, let me start. Hello students, good morning. Myself Professor H.J. Remat from Department of Civil Engineering, KLS VDIT, Halia. Students, in the last online lab, we have discussed about how to determine the percent of available free chlorine in a given bleaching powder sample. And today we'll discuss about the determination of chloride content of water. So this is the title of the experiment. So that is determination of chloride content of water. And let us come to the introduction part. So chlorides occur in all natural waters in widely varying concentration. The chloride content normally into this as the mineral content into this. Upland and mountain supplies usually are quite low in chlorides, whereas river and groundwater. Yes, students, wait for some time. There is a noise. I'll tell them. Yes, sorry for the disturbance. Okay. Yes, Divya. Divya. Chaitra.
Yes, sir.
Yeah. Is it audible?
Yes, sir. Audible.
Raghavendra.
Yes,
Yes.
sir. Audible, sir.
Audible, and whether the screen is visible clearly.
Yes, sir. Yes, sir.
Okay, then let me continue. There was a disturbance. Okay, so let me continue. Now, as I told you, the upland and mountain supplies usually are quite low in chlorides, whereas river and groundwater usually have a considerable amount of chloride. Sea and ocean waters represents the residues resulting from partial evaporation of natural waters that flow into them, and chloride levels are very high. Chlorides can exist to natural waters in many ways. The solvent power of water dissolve chlorides from topsoil and deeper formations. Spray from the ocean is carried inland as droplets or as melted salt crystals, which result from evaporation of the water in the droplets. These sources constantly replenish the chlorides in inland areas where they fall. Ocean and sea waters invade the rivers that drain into them, particularly the deeper rivers. The salt water, being denser, flows upstream under the fresh water which is flowing downstream. There is a constant intermixing of the salt water with the fresh water above. Groundwater in areas adjacent to the ocean is in hydrostatic balance with seawater. Overpumping of groundwater produces a difference in hydrostatic head in favor of the seawater, and it introduces into the freshwater area. Such intrusion has occurred in many areas of the coastal southern region of Bangladesh, and also you can see such situation in nearby Karwar Ocean. Human excreta, particularly urine, contain chloride in an amount about the chlorides consumed with blood and sorry, it is not blood, it is food and water. This amount about 6 gram of chloride per person per day, and increases the amount of chloride content in municipal wastewater about 15 mg per liter above that of the carriage water. Thus, wastewater effluents add considerable chlorides to receiving streams. Many industrial waste, for example, you can say the wastewater generated in tannery industry, also contain appreciable amount of chlorides. Now come to the significance of the experiment, why this particular test is necessary. Okay, so chloride in reasonable concentration are not harmful to human. At concentration above 250 mg per liter, they give a salty taste to water, which is objectionable to many people. For this reason, chlorides are generally limited to 250 mg per liter in supplies intended for public use. In many areas of the world where water supplies are scarce, source be containing as much as 2000 mg per liter are used for domestic purposes without the development of adverse effect once the human system becomes adopted to the such water. Now, let us start today's experiment. Yes, Sahana.
Yes, sir.
Yeah, are you there?
Yes, sir.
Is it audible clearly?
Yes, sir. Audible.
Okay. Subha?
Yes, sir.
Yeah, okay then. Okay. Now, let me continue. Now, come to the aim of today's experiment. Our aim is to determine the chloride content of the given sample of water. And what are the apparatus required for the determination? So here we require burette, measuring cylinder, conical flask, wash bottle, etc. So as we did for other titration experiment, we require these apparatus. So this is the burette with stand, this is the measuring cylinder, conical flask, this is the wash bottle. Now come to the reagents required. So here basically we require two reagents for the determination of chloride content. First one is potassium chromate indicator, that is K2CrO4, and second reagent is silver nitrate of normality 0.0141N. So these two reagents are required, and we have prepared these two reagents in our laboratory using the chemicals. And if you want any information about the preparation of these reagents, so just go through the manual of VDI related to environmental engineering laboratory. Yes. Now come to the procedure part. Yes. Pratiksha Patel.
Yes, sir.
Is it audible clearly, ma'am?
No, sir.
Have you heard the reagents required for the experiment? Yes.
Yes, sir.
Tell me, which are the reagents required? Hello, is it audible clearly? Yes, Raghavan. Raghavan,
Yes, sir.
tell me the
Audible,
reagents.
sir, audible, sir.
Now it is not audible. Hello.
Audible, sir.
Audible.
Audible.
Now tell me the reagents required for the determination of chloride content. Just now I told you.
Potassium, sir.
Potassium chromate. Next. Silver nitrate.
One more, sir.
AgNO3, that
Sir?
is silver nitrate. Okay. Yes.
Good night.
Sudha.
Sir.
Sudha.
Yes, sir.
Yeah. Have you heard about the reagents required?
Yes, sir.
Tell me which are the reagents required for the determination of chloride content?
Potassium, chromate, and silver nitrate.
What is the normality of silver nitrate?
0.01.
0.014. Okay. Okay then. Let me continue. Now, come to the procedure part. To start with the experiment, take 50 ml of sample in a clean conical glass. Now, this is very important step here, second step. So adjust its pH between 7 and 8, either with sulfuric acid or sodium hydroxide solution, because there will be a formation of silver hydroxide at high pH level. Understood? If the water is too alkaline, then there will be a formation of AgOH, then you will not get the required colored solution. Understood? So that's why in the second step, we have to adjust the pH between 7 and 8. If at all the pH is very less, it is less than 7, just add NaOH to increase pH, and if the pH is more than 8, then add sulfuric acid to reduce the pH. Okay. Now, in the third step, add 1 ml of potassium chromate to get light yellow color. Okay, when you add 1 ml of potassium chromate indicator, then the color of the solution will be yellow. Now, in the fourth step, titrate with standard silver nitrate solution till color change from yellow to brick red. In fifth step, note down the volume of titrant added in ml and repeat the above procedure to get average value that will be considered as AML for at least 3 samples of water. Sixth step, for better accuracy, titrate distilled water in the same manner. And the seventh step, note down the volume of silver nitrate added for distilled water that will be considered as VML. So let us come to the observations. First observation is that the value of sample considered for the determination of chloride content, that is 50 ml. And second observation, I can say titrant. So here we are using silver nitrate, that is AgNO3 of normality 0.014. And third one is we are using indicator as potassium chromate. And what is the end point of the reaction here? That is color change from yellow to brick red. So these are the observations. So before going for the tabulation and calculation, so let's have a look over the video, or we'll watch the video which shows the conduction of the experiment. Yes, Sahana? Yeah. Sahana?
Sir, screen is not
Sir,
visible, sir.
screen can't tell us, sir.
Now I have removed that particular screen. Okay. Now we'll discuss the tabulation and calculation afterwards. Okay. So now I want to play the video related to conduction of the experiment. Okay. Students, let us have a look on the conduction of the experiment to determine.
Sir, screen is not visible, sir.
Now is it visible?
No, no, sir.
Now it will come. It takes some time. Yes, Raghavan.
Yes, sir.
Now is it visible?
No, no, sir.
No.
It is showing only the introduction page, sir.
It is showing only the introduction page.
Yes, sir.
Okay, I am playing this directly through WhatsApp because we have not downloaded here. Now, you are not seeing my screen, Raghavan?
Yes, sir.
Audio,
Sir,
you are not seeing my screen.
yes, I am seeing a screen, sir, but only the introduction page is seen to it. So no videos is playing, sir.
Only the introduction slide is visible, na?
Yes.
Yeah. Okay. Let us. No, it is not easy to download here. Okay. Now, whether the audio is, whether my voice is audible in the video, the
Yes.
chloride content of the
No, sir.
pH water sample.
Yes, yes, sir. Yes, sir.
Speaker, you can see the water sample, a graph only audio, not video from
Yes.
our cap. To start with the experiment, first you check the pH of the sample of water. Students, as you can see, this is a pH meter. It is already calibrated. Now, immerse the electrode in the water to be tested for pH. Wait, we'll get a constant reading on the pH meter. Now, you can see the constant reading, that is 8.68 on the pH meter. So now, as per the procedure, so we have to adjust the pH of the sample in between 7 and 8. Now, as you can see, this water sample is alkaline. Just add 1 drop of sulfuric acid to reduce the pH of the sample. Now we are adding concentrated sulfuric acid and stir it with a glass. Now again test it for pH. As you can see, we have adjusted the pH of the given sample to 7. Students, the first step of determination of chloride content, just take 50 ml of sample in a clean conical flask with the help of measuring cylinder. Now add 12 ml of potassium chromate in it. This is the addition of potassium chromate indicator. Now, as you can see, there is a color change. There is a formation of yellow colored solution. Now, titrate this yellow colored solution against standard silver nitrate of normality 0.014 unless you will get a brick red colored solution. Now, as you can see, there is a development of brick red colored solution. Just you note down the value of titrant run down. Now the initial burette reading was 0. Now the final burette reading is 11.5. Repeat this particular procedure for at least 3 samples of water to get the average burette reading. So that may be considered as AML. Now, in the next step, for better accuracy, we'll consider blank reading. So that means we'll titrate the distilled water against titrate. For that, just take 50 ml of distilled water in a clean conical flask and add 1 ml of potassium chromate indicator. So this is the addition of potassium chromate indicator. Now shake it well. So now add slowly the titrant to distilled water. As you can see, a drop or half ml will impart brick red color to the water. So just you note down the final burette reading. Now, initial burette reading was 0. Now, the final burette reading is 0.4. This particular procedure, or at least three samples of distilled water, know the average burette reading, so that can be considered as PML. Both A and B are required in the calculation of the chloride content of the water. Okay, students, thank you, one and all. Yes, Raghavendra.
Sir,
Was it the audio was clear of the video?
the audio is clear, sir. But
We were unable to see the video, I think, isn't it?
yes, sir.
Yeah. So, students, let me request you to go through YouTube channel of the Civil Engineering Department to watch clearly the video related to conduction of this chloride content. Okay, the video uploaded today itself. Just you can watch over the YouTube channel of the Civil Engineering Department. Yes, Sudha.
Yes, yes, sir.
Sudha.
Yes, sir.
Yeah, I think we were unable to see the video, isn't it?
Yes, sir.
Let it be. Okay, I will upload this video in YouTube channel, ma. Okay, you can just watch in YouTube channel.
Okay,
Okay,
sir.
so let me continue with the tabulation part of the experiment. So this is the tabulation. Now, the first column, as usual, that is sample details, and the second column will be for volume of sample in ml, and third column, which again consists of three sub-columns. Third column will be burette reading, which consists of three sub-columns. That is, first column is for IVR, that is initial burette reading in ml,
Excuse
and
me, sir.
second one is, yeah,
The screen is not visible, sir.
now it is not visible.
No, sir.
Is that Sudha? Let me share once again. Sharing. Yes. Sharing is there. Yes, Raghavendra.
Not visible, sir.
Screen is not visible.
No, sir.
Possible. Now is it visible, Raghavendra?
Yes, sir.
Now is it visible?
Yes, yes, sir. It is visible now, sir.
Sudha.
Yes, sir. Visible, sir.
Visible. No. So just I
Yes.
have connected and I have connected. Okay. So let me go through the tabulation. So as usual for titration, that is first column will be for sample details and second column will be for volume of sample in ml, and third column will be for burette reading, which again consists of three sub columns. First column will be for IVR, that is initial burette reading, and second one is final burette reading, and third one by deducting FBR with IBR will get third column, that is ml of titrant, rundown or utilized. Okay, so in the video itself, the initial burette reading was 0, and final burette reading is 11.5, and the ml of titrant rundown is 11. This is 11.5 minus 0. That will be 11.5 only. And after that, you can adjust the initial burette reading to 0 again by adding titrant to burette. Now, the second reading may be 11.6, and the ml of titrant utilized will be 11.6. And third, again adjust the burette reading to 0 by adding titrant to burette, and third reading may be 11.7. So it will be 11.7. Now, if you take the average of 11.5, 11.6, and 11.7, the average will be 11.6. So which we can consider it as A ml. And second one is, that is for distilled water for blank reading. So initial reading of the burette, you can adjust it to 0.0 by adding titrant. After that, in the reading, we got the final burette reading for distilled water as 0.4. The volume of titrant utilized will be 0.4, and here again you can adjust it to one reading is sufficient, but anyhow for average you can consider 2 or 3 readings. So second reading may be 0.4 itself, and third may be 0.4, 0. Initial burette reading is 0, and final burette reading is 0.4. So the ml of titrant will be 0.4 only, and 0.4. Average burette reading for distilled water, it is 0.4 only. Yes, Raghavendra, are you able to see the entries?
Sir.
Yeah?
Yes, sir. Yes, sir. It's visible, sir.
Visible. I have entered all the readings from the video. Okay.
Yes.
Is it clear?
Yes, sir.
Is there any doubt?
Yes, sir.
You have doubt?
No, 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 no doubt.
Okay. Very clear. So, as I told you, the chloride content, chloride content in mg per liter equal to, that is in bracket, A minus B into normality n, that is 0.014, and next one is equivalent weight of chlorine, so that is 35.45, and into 1000 So whole thing divided by volume of sample. Volume of sample. So that is, let me reduce the size of the font. Yes. Now, as you can see, this is the formula used to calculate the chloride content. So that is A minus B. A is ml of titrant, average ml of titrant used in color change from yellow to brick red. So that is A is 11.6 and B is 11.4. So let me substitute all the values here. A is 11.6 minus 0.4 into equivalent weight, that is 35.45 into secondly we have to substitute the normality 0.014 into 35.45 into, here it is 1100, okay, 1000 into 1000, whole thing divided by volume of sample. So here volume of sample we have considered is 50 ml. Now just calculate this with the help of calculator. That is 11.6 minus 0.4 is 11.2 into 0.014 into 35.45 into 1000 divided by 50. So the calculation is, that is 111.17. This is, that is 111.17 mg per liter. So you can write down the result like the chloride content of given water sample is 111.17 mg per liter. So based on this result, you can conclude that the water may be used for consumption or it is potable. Okay. Raghav,
Yes, sir.
yeah, I have gone through the calculation part.
Yes, sir.
Yeah.
Yes, sir.
Is there any doubt? Is there any doubt?
No, no, sir.
No. Sudha? Sudha? Sahna? Yeah. Hello, Sahna.
Yes, sir.
Yeah, I have gone through the calculation part.
Oh, yes, sir.
It was visible, no?
Screen is not visible, sir.
Screen is not visible. Everyone is able to see the screen. Okay then. Pratiksha Patel.
Yes, sir.
Yeah, I have gone through the calculation part.
Sir.
Yeah. Is there any doubt, ma?
No, sir.
Okay then. Okay. So let me conclude the lab, and in the next online lab, we'll conduct an experiment to determine one of the characteristics, that is conductivity of water, and also, if possible, we'll conduct another experiment, that is BOD determination, that is biological oxygen demand determination. So here with this, let me conclude the class. Thank you, one and all.